social welfare and fairness. Improvements in targeting performance translates to an increase in social welfare using the constant relative risk aversion CRRA utility function. Again, the CRRA is the constant relative risk aversion utility function. We calculate aggregate welfare under the phone-based approach, and each of the counterfactual targeting approaches under the constant relative risk aversion assumptions. Individual utility is a concave function of consumption. By assuming a fixed budget, which we fix at a size analogous to that of the Novice Rural Aid Program, which had a budget of $4 million to distribute among 154,238 program registrants and equal transfer sizes to all beneficiaries. We simulate the distribution of benefits among the eligible individuals at counterfactual targeting thresholds to construct social welfare curves for each targeting method. This social welfare analysis also allows us to identify the optimal beneficiary share and corresponding transfer size. Figure 2 shows the utility curves for each of the targeting methods simulated separately for the two populations. Note that phone-based targeting, geographic blanketing, and an asset-based wealth index all achieve approximately the same maximum utility in the hypothetical national program, but phone-based targeting dominates in the rural Novice program. Also note that all targeting methods outperform a universal basic income scheme if the beneficiary share and transfer size is well calibrated. These utilitarian welfare gains suggest that society as a whole will benefit from improved targeting, but do not imply that all subgroups of the population will benefit equally. Indeed, there is growing concern that algorithmic decision-making can unfairly discriminate against vulnerable groups. To address these concerns in the context of the Novice program, we audit the fairness of each targeting method across a set of potentially sensitive characteristics, while noting that notions of fairness and parity are contested and often in tension. Figure 3A shows as an example that the phone-based approach does not cause women to be systematically more likely to be incorrectly excluded by the targeting mechanisms for receiving benefits than men. See also methods, fairness. Similarly, the phone-based approach does not create significant exclusion errors for specific ethnic groups. Figure 3B, religions, age groups, or types of households. Though there are small differences in targeting accuracy between groups, extended data figure 2, we also compare the fairness of the phone-based approach to several other targeting approaches by evaluating each method's demographic parity, that is, the extent to which each method under or over targets specific demographic subgroups relative to that group's true poverty rate. Figures 3C, D, extended data figure 3. Overall, we find that none of the targeting methods analyzed naively achieves perfect parity across subgroups, a phenomenon referred to as no fairness through unawareness. The largest parity differences occur with geographic targeting methods.